Hello there, my name is Tero Hanula, and today we will add more functions to save and load a neural network, but this time by using buffers. Just to remind that we will be using Game Studio 2.3. To start with, JSON is really good at representing arbitrary data, like a network structure. It is just we have a lot of numbers to store, which are much better stored with a bit format to be memory efficient. So let's do that exactly. Store layer structure as a JSON string, but have parameters stored as floating point numbers. For saving a structure, we will have similar steps as in the last video, but leave out parameter references from dummies. We could store structure and parameters as two separate files, but instead I'll put them in same buffer. As in GMS2, we can choose how to read and write the bytes, so we can mix text and numbers in same buffer. We will first stringify structure as JSON, and then write this into a buffer. Rest of the buffer will be just numbers. Of course, as separate files you wouldn't need to worry about this, but in another hand, single file is easier to handle. A number is represented as a fixed amount of bytes, like a 32-bit number with a 4. A string instead has a variable amount of bytes, and each of them represent a character from text. For now, parameters will be saved as 32-bit floating point numbers, but I'll change that later to support definable accuracy. I have used growth buffer, so GMS2 automatically resizes buffer as we write more bytes. Buffer will grow in powers of 2, so it is good to trim buffer to final size before returning it. I'll do some tests like in last video to make sure function actually works. I'll save network, but I will put buffer in an actual file. With a getFile function, you can also cancel the action, so it is good to make check for that. Now for testing, I will first cancel action, and then I'll try save the buffer into a file. This should work just fine, and the result should be a file holding the content of our buffer. We can try reading this file in Notepad, but only the JSON part is readable with a correct format. The numbers will be shown as a random mess, but that's fine as Notepad just don't know how to represent them. Back to coding. Our loading function will take buffer and it doesn't care where it comes from, like it can made during the game or from our previously made file. Like before, we let user decide whether network will have taped layers or not. We will want to wrap our code with a try-catch block as outside data can be malformed. For loading, we need to follow steps we have used in saving function. So currently, we know buffer will start with a JSON. So let's read first a string from buffer. To get a structure from this, we can follow same steps as in previous video. So we can pass JSON, create network, and load a structure for it. After we have read a string from buffer, we know rest of the buffer is just our numbers for parameters. The parameters should have been written in buffer sequentially with the assumption that layer structure represents enough to read correctly, which will always move seek position with a fixed amount. Buffers have this innate seek position or header, which tells current byte position where buffer will read or write. This will move with these operations, so we don't need manually set position. The peek and poke functions are for editing bytes at the explicit position, but currently we don't need them. As a string length can vary, they usually have one extra terminator character at the end to tell when to stop reading. This is the case with our JSON part too, but GMS2 will handle that for us. Finally, we can test loading. Let's try with our previously saved network. If loading was successful, then copy network to the whole population to see clearly something happened. As we have saved some random specimen, most likely whole population will run over the edge after loading. And that's what they do. Let's move on to the next thing. Currently, we can only save with 32-bit floats. If we want to be able to choose from 16, 32 or 64-bit numbers, then our functions need to be changed a little. We want to store this information about the number format, the accuracy, in which parameters are stored. I think the best way would be modifying our JSON to include this. Currently, our JSON is array of dummy layers. Let's wrap them with a struct. With this little abstraction, we can hold meta information about a save file outside the layers, like the accuracy. We can easily modify this struct to accommodate other things. Now for final test, I'll convert string-wide network from last video into our new save format. I can just copy-paste it to the game. By doing this, population has loaded pre-trained values and we can use them to make a save file with our new buffer format. By restarting population and then loading with a buffer format, we can see that it does work. Specimens still avoid the blocks. For this last test, I had set accuracy to 16-bit floats, and specimens seem to behave the same as before. So there hasn't been decline in performance, and for this small network, we can store parameters with a lower accuracy. Now finally, on the left is network stored by using only JSON, and on the right, same network but using new buffer format. It is multiple times smaller in size, which is a great deal with larger networks. If you wonder, can we visualize contents of the buffer at all? I will say yes, with asterisk. It is not possible with a notepad, but with a GMS2 debugger, if number bytes are aligned properly. Most likely they are not, but you can add padding after JSON, so number bytes are aligned. I think in the next video I'll do arraymax and softmax layer types. These are usually used at the end of the network to make network do selection. But that's for later. See you then. Mukavaa päivänjatkoa. Moikka!